And now I'd like to invite to the stage Gianfranco DiCicco, who's the DFI trustee liaison to the Project Information Management Systems and the secretary of the DFI. He will be moderating our next session.
Well, first of all, thank you to the committee to have us here, the conference committees, and I want to invite here up with me the presenter of the of this incredible, for me at least, session, which want to show you a little bit what should be the future in our industry. So let's start here. This one, right? Okay. So, Project Information Management System Committee. What is this? Why? Why this name? We started 2 years ago, and most of us work together in one project or the other, and we represent really all the industry. We are missing the academia, which we are trying to have with us too, because we have owners, of course, represented. We have contractors. We have engineers, and we have a consultant that developed the tools that we need for the future, and we need it already now. And then it's me that I don't understand anything about this, but I have so many ideas, and then I just said why we should not be here starting this before anybody else and try to understand what's going on, how we are going to be prepared for the future. In dealing with what? Dealing with digitalization, dealing with computers. I don't want to take a lot of time because they are the star of the presentation, and I want to go ahead and we can talk a little bit after. But just remember one thing. If we don't do what this four incredible people are telling you to do, you're not going to be in business very soon. We are changing completely. What we have now, the computer, everything will disappear very soon. We will work with our hand. We will do things that we don't imagine. So I'm going ahead and introduce Massimo first, the start, and then you will see what's going on. I hope you enjoy.
Okay. Notes. Yes.
Sorry, I want to help you.
Oh, that's fine.
Oh, you need presenter mode? Yeah. All right. It's on the webinar, so that's what the webinar is going to see too.
So, in our everyday life, we discover new concepts. We use new words, which become part of our vocabulary, and that we use in our communication. Some of those words, concepts, or ideas are used very often, and we can find them almost everywhere. And when I say everywhere, I really mean it. One of those words is big data. Okay. I was at Heathrow Airport a few days ago, and instead of advertising cars or watches or stuff like that, they were advertising information technologies, and specifically big data. Why in an airport they should advertise big data? Well, big data is definitely part of our life. We have data everywhere. Our phones, our smartphones are generating so many information, so many data. And in every 2 days, we generate almost the same amount of data that were generated since the beginning of the human history till 2003. So it's a huge number of data. Someone think that in 2007, the number of bits of information in our digital universe has exceeded the number of stars in the physical universe. So, but should our industry be somehow big data aware? Let's explain what is big data. Big data can be defined by these 3 + 2 + 1 V dimensions. The first V is volume. It's simple. The amount of data that we are generating. Velocity is the speed at which we generate those data. We read piezometers every minute or every second. This is the speed. And then we have variety. Variety is different type of information that we are generating. Can be just a text, can be a reading from a piezometer, can be a picture, can be some different things. And then we have 2 more V's. Veracity. So we want to be sure that what we are collecting is true. And valence. We want to understand if there are relationships between the data that we are collecting. Along with the definition of big data, we also have some challenges. So volume goes with data storage, backups, bandwidth, how big our computer must be to collect all those data. The challenge with velocity is real time, provide information in a very usable way. That means bandwidth, computer power. And then variety goes with complexity. So we do not have tables or rows anymore, but we have some different facts that can describe the information. And then we have veracity. We want to be sure about quality, about accuracy, and reliability of what we are collecting. And last but not least, relation between data and how much dense are the connections between the data that we are collecting. So in our industry, should we think about big data? Are we really involved in this big data stuff? Well, if we think about Twitter or Facebook, well, probably not. But just think for a minute, we are collecting data from a piezometer, actually 50 piezometer on a job site. And we are collecting data every single second. And we are doing this for 40 years. And then suddenly we have an alert coming from one of those piezometers while we are grouting. So what we want to do is verify the grouting process in real time and compare it with the spike that we have seen on that piezometer or with piezometers in that area. So we do not have the power and the money that Facebook or Twitter are putting on this job. But if we think about our equipment in terms of computer power, and if we think about skills, we probably need to address these problems with a big data approach in our industry. Did I forget something? I said 3 + 2 + 1, the 6 V's, but I just spoke about 5 V's. So speed, velocity, volume, valence, variety, and veracity. What about the 6th V? The 6th V is the most important one. Is the value that we can find hidden in the information, in the data, and is the value that we want to bring out and pull out from the data. I want to introduce Mark. He will discuss 3 topics in information management from a user perspective.
Okay, that will go. Which way? Just click down there. Okay. All right, well, good morning.
You don't need these notes, right, because you have these?
No.
Okay, just a moment.
Oh, thank you. Okay. I want to talk about project information management for dummies. And when I mean dummies, I'm talking about me. I serve on the Project Information Management Systems Committee with Gianfranco, Vanessa, Massimo, and Jamey, and I'm constantly awed about their capabilities and their depth of knowledge in information management. As an engineer or an engineering manager, I'm a user of information management systems, not a creator. 23 years ago, I worked on a project where we had an internet-based system that would show construction progress and schedule progress. Today, we can do that and much more. When I think of information management, I want to think of what it could do for the project, what it can do for me, but I also want to ask, what solutions can you guys give me to make the job run better, faster, cheaper, and with less risk? And I also want to know, what are you going to give me for the budget that I'm willing to provide? As Massimo said, I want to discuss 3 topics today. Each topic will have an idea for future use. Some of you in this room are probably already using those ideas. Others, it may spark a different idea. Let's think about these together. First of all, large data sets have been stored and used for a long period of time. In the ancient world, one of the big stores of data was a library in Alexandria, Egypt, that was created by one of the pharaohs in about 300 BC. People would spend their entire careers studying at that library. Well, why on earth is that relevant today? Well, people used that big data then to answer big questions. One of the questions that was answered then was by a Greek mathematician who was able to be the first person to accurately measure the circumference of the Earth. Well, so what is different about big data now? Massimo talked about 3 plus 2 plus 1. I'm going to talk about just the first 3. Tony Kiefer earlier talked about automated monitoring equipment. Well, first of all, there's a variety. You have machine parameters, soil and rock test data, concrete test data, installation parameters, water levels, slurry density and viscosity, grout takes, grout composition, grout flow, pressure, rotation speed, lift rate, spoil return, pump strokes, hammer blows per foot, hammer energy, hammer stroke, hammer rate, and many more. And that may be just for 1 or 2 activities. So with all of the variety of data being taken, there is going to be a lot of volume. For example, in one activity, grout composition, grout flow, grout pressure, rotation speed, lift rate, and spoil return may be measured every second, every 5 seconds, 10, 15 seconds. Okay? So with those data sensors taking all that data is coming in fast with a lot of velocity. And add other activities with variety, you're going to have a lot of big data. And some of that and I would say even some of that, think with me here, some of that variety in volume and velocity might even get Mike Wysocki to liken drilled piles and cast-in-place concrete. So we have big data. What can we use big data for? Well, let's think a little bit about an analyst who wants to get things right to the nearest thousandth. Or let's think about a drill rig when we get a report filled with weight of hammer blow counts in dense fine sands. Well, what's a connection there? Well, a connection is a geotechnical report. Does a geotechnical report need to be a PDF file? Can it be a database with a 3D model? Geo-referenced? There should only be, think about this, there should only be one data entry point for data. And that's the initial entry. Everything after that should be transmitted digitally. We need a database of results, interpretations, and cautionary tales placed in a geo-referenced 3D model. And then take that and work with your analytical and design tools, your construction tools, turn that over to your owner. And as well, as Bill Walton talked about, big data can be used to confirm performance. So let's think about future forward. Well, on the right, here's a picture of a single entry data with a single picture done once to evaluate something. We need to have that in a model, a 3D model in a database, so that all project participants have access to that information. My second topic I'd like to think about is anomaly detection. Gather data by hand, tabulate data by hand, plot data, evaluate data, figure out what's going on. Or on Rich Finow's observational approach for excavation movements, data collection, data analysis, and curves. Well, what have we done to help that? Well, we got automatic data acquisition there on a job shown on the right. But what about using machine learning? Can we run the tests and the examples to use that data to learn things? Can we look at and act on indicators of dam failure? Look at equipment reliability and operation. Operate batch plants. Look for geologic anomalies. Look at anomalies in concreting piles. Third topic I'd like to talk about is virtual reality. And realize that many projects now are designed in a 3D model. It's used to manage and visualize data for design, construction operation. Previously, we would create a 3D model there on the left, which was a model of the Black Fox nuclear plant that was never built. But think about that for a second. Drawings now are views, are byproduct of the 3D model. You can have the model as the single source of information. A drawing is a visual state of the model at any given time, and there's flexibility on how to view that information. You can take a 2D orthographic projection of it. You can take an isometric view. You can have a table of attributes in that drawing, and all engineering disciplines have access to that 3D model. Well, what's one of the good uses of that model? Since everything is dimensioned in that model, clash detection or interference detection is an important part of using that model. So that process can be managed. You might have some rules like cast-in-place concrete takes precedence over plant piping or some other rules, and then look at the rest of the interferences to figure out where things go. So it provides access to synchronized and connected project data. You see multiple disciplines at once. I want to say a lot of projects have a 3D above grade model, but don't have a 3D underground model. So let's make that a part of a typical project. That model with underground features then can be used in analytics and carried forward through construction and then operation. A 3D model has various uses throughout a project's life cycle. First of all, in planning, you can have the project stakeholders look at a rendering of the project. You can do a virtual reality tour of the project. During design, there's a lot of things you can do. One of them is to perform your quantity takeoffs to get your price for that. You can provide tags for what location is this, what system is this, or other attributes. During construction, you can use it for construction planning to say, okay, here's my equipment placement that I need to have to do this. You can look at leave-outs where you want to place large equipment later. You can get quantities for certain areas or systems for construction planning. And then last, you've got the turnover to at the end of a project to the owner. And what can be transferred? Well, you've got equipment information that can be put on schematic diagrams. You've got as installed geometry. And let's say here, folks, here's our pile plan. I want to click on that pile right there, and I'm going to see the installation log. I'm going to see all the test results for that pile, and there's the load test results. So future forward, let's talk about augmented reality environment and what I want to see in a facility. I'd want to carry this piece of equipment or a tablet around with me on site. It's got the model embedded in it. So as I walk around, I can see, well, wait a minute, here I'm entering the door, okay? I might have some other attributes in it, okay? There's the main gas line that I have to avoid. And, oh, by the way, over here, here's this POW group that needs to avoid that underground utility. That technology is available now. Take a look around. Some of the vendors here have these capabilities and more. Let's keep our industry current and looking forward in data management. Thank you.
Let me continue my journey inside the Heathrow Airport. One extra advertisement, machine learning. And you just touched that, right? Yes. Okay, so really, these words are everywhere around us. So what is machine learning? Machine learning is a computer science field that is focused on creating models, not programming a computer, but analyzing a set of data. So we feed the computer with a set of data, and the computer learns what is inside those data. Machine learning is the intersection between computer science, math and statistics, and domain knowledge. Without domain knowledge, we cannot build any model. There are different names that basically belong to the same concept. So we hear about predictive analytics, we hear about data mining and data science. All these different names use the same techniques to analyze data. And the four basic techniques are classification, regression, cluster analysis, and association analysis. So classification, given some categories and a data set, we want to find the category each sample belongs to. Some examples are, will it rain tomorrow? So the category are just yes or not. Or can we understand the sentiment of a Twitter and categorize it as a positive, negative, or neutral. So categories and a data set. Regression. Regression is about finding a number. So it's not about finding a category, but it's about finding a number. What will be the price of the stock in the next, 10 days? And then we have cluster analysis. Cluster analysis is organize a data set, so items, into groups. So it's kind of the opposite of classification. Understand the classes from the data set itself. And then association analysis. Maybe someone of you knows about the story of a big retailer that in early 90s discovered that there is an association between diapers and beers. So people that go to buy the diapers also buy beers. This is a classic example of association analysis. Well, again, should we be machine learning aware in our industry? Absolutely, because machine learning will help us in improving safety, productivity, and efficiency. I can give you just an example of machine learning. We can automagically populate a borehole log. So we have a real-time rig data coming from the rig. We apply a classification algorithm on that, and then we have core samples, pictures, and we apply a cluster analysis on that. We apply the machine learning algorithm, and we can automatically generate a borehole log. Who's next?
I'm next.
Jamey.
Thank you. I get to talk about the current state of the practice. And this is a really exciting time for information management in the Geo Foundation's world. Over the past decade, we've seen more and more vendors and owners and contractors digitize or digitalize their data, recognize the need for information management, and apply just some fantastic technologies. And if you walk around the exhibit hall this week, you'll certainly see them. So the current focus of our industry seems to be on data collection, data compilation, putting it all in one place, visualizing it, of course, and then accessing that data. And we're starting to really focus on analysis. I know, of course, we've been analyzing data since the beginning of the industry, but now these analyses are more and more showing up within databases, within information management systems, and part of the whole practice. And the next steps seem to be including prediction, using the data we have available to predict the future with increasing accuracy. And these are being driven by pretty basic needs. We all want to increase the quality of our projects, and that might be as simple as catching and correcting errors right at the point of data collection or data creation. We want to increase the efficiency, of course, to reduce risk. And this might also have the added financial benefit of automating common functions and reports, and we'll show you some examples of those. And of course, we all want to serve our customers, especially if those customers are providing detailed specifications that are describing in great detail the information management system that are required and how to provide it to them. And the good news is we're developing technologies meant to meet these specifications that can then be applied on smaller projects or projects that may not have owner specifications anywhere near as onerous. So this is certainly a positive direction. So information management systems usually start with project planning and then continue with data entry or data creation, if you like. So as an example, here is a mobile phone, and I'm standing next to a pile being installed, and I can use my thumb to select the pile from a drop-down and enter some dates and times, maybe some as-built depths and some other observations. And when I click this little checkbox here, it's going to quickly check for errors. And this is good news because it may tell me that the date I entered doesn't make sense because it's in the future, or the depth I entered doesn't make sense because it's much deeper or much shallower than what was expected for that pile, or it might be more sophisticated with some of the regression tools that Massimo described. It may say that the metric we've just entered is not in line with a current trend, so it may not be an error, but it's something worth checking. So before we even send this data anywhere, we've increased the quality and corrected these errors. And then it's going to send the data to the mothership somewhere, a cloud database or an enterprise database, and be immediately accessible in maps and reports and tools. If we share with the owner, they can see that 30 seconds ago a pile was installed, and and we could keep them happy and maybe calling less, or keeping everyone just on the same page. Once you've collected data, we need somewhere to put it. So the next step in an information management system would be compiling data into usually a single database. And when it's all in one place, we know where it came from, which is extremely important for archiving, for risk management, et cetera. We could find the data we need, and we can facilitate the types of automation that are going to save time and ultimately money on these. So a typical information management system workflow on a GeoFoundations project is pretty straightforward. We have a whole bunch of data sources. We collect the data. We put it all into a database. That's this tank here. It's an enterprise database because it's web accessible or intranet accessible. And then the data is served to maps and reports and outputs and drawings and anything else that we may need to do. And it's very exciting to see how these workflows may be evolving in the near future with distributed databases and networks of Internet of Things instruments and then all sorts of great stuff. And then once compiled, we can fairly easily visualize this data. So as an example, let's say you have a spreadsheet with digital borehole log information, or maybe you keep your borehole logs in software like GINT, something that has a digital record of geology identified along stages. And then when those same holes, we might be injecting grout, and we have a record from a grout monitoring device of grout takes. It should be fairly straightforward in a database to just assign some quick, dirty, random color to the geology, see how the geology changes along the boreholes, and then use that same geospatial context to look at, in this case, the grout takes, color-coded as a function of grout injected, and make some conclusion about the relationship between grout injected and the bedrock geology into which it's being injected. And visualization might mean a lot more than just creating a picture, and then the industry is really exploding with all sorts of interesting and novel ways of visualizing simple and complex data. And it might be as simple as an executive summary, like one mobile phone screen of just what I need to know that day, or something much more sophisticated. But ultimately, at least in the current state of the practice, there's still the need to print a report or create a drawing or create something static and submit that to an owner. And that's just fine. So a lot of our data now is geospatial and geometric. And a first step in getting to that geospatial world is just recognizing tabular data. So this is a very simple visualization, and I call this an executive summary. It's literally telling me for this grout curtain how many boreholes have been grouted and water tested along a kind of a modern gauge style, total grout injected, and I can look at this screen and know where I am without needing a spatial component yet. The next step would be to add some sort of aggregate or cumulative analysis to it. This is a typical grout closure plot, which has been in the industry for years. I'm just looking at the total grout injected in a primary holes or all the primary holes versus secondary, tertiary, et cetera. But you can see here, this being an interactive web tool, I've made some selections in little checkboxes. I said I don't want to see the V line for whatever reason, and I may slide this slider around to look at a range of dates, select a range of stations, and immediately update this grout closure plot to just what I want to see. Still not quite spatial though, and the real focus in the industry now is on this spatial world. A lot of our data is three-dimensional in nature, especially when the subsurface comes in. So our databases are increasingly seeing the need to be spatial themselves. And with a spatial database, you can view things in a common context, a common spatial context. So like this is a profile view of a diaphragm wall where we're sticking a whole lot of information in one place. You can see we've clicked on a panel, as Mark said, and opened up everything we know about that panel. We're looking at a visualization of the geology encountered during the excavations, and we have some color-coded verification holes showing pass or fail of simple tests. So everything in different data sources in one common thing, which is really a common theme here. 2 dimensions might not be enough. We may need to go to 3 dimensions. And here we have a geospatial database-driven 3-dimensional model of the Bluestone Dam. This is an Army Corps facility where you can see there's CAD and microstation model parts that have been added to the model. And then we've connected that to the database so we can visualize, for example, in this case, corrugated grout along geotechnical anchors as a function of their compressive strength. Typical kind of way of taking 3D static features and making them actionable with information management systems. So continuing with the geospatial theme, geographic information systems, GIS, and building information modeling, BIM, very common in Europe. is getting more prevalent in the industry. And here's a typical way that we use GIS technology to keep track of, in this case, a diaphragm wall along a dam. This is the Bolivar Dam. And because this is going to play, we can turn on or off the layers we want to see on the website, we want to render. We can zoom in like in a Google Maps environment, in this case on the curve. Let's zoom in a little further here and look at some of these panels in detail. Click on something to interrogate the database, tell us everything we know about it, but more importantly, show the results of geospatial analyses. So here I've selected, in this case, a 30-foot depth cut, and I can look at the actual position based on three-dimensional data of our overlaps between adjacent panels, color code them whether or not they're in tolerance. Of course, they're all green because they're all perfectly installed. And click on these to look at the verticality data right at that cut. And these are getting more and more common, as you'll see hopefully in talks through this. Now, this is the fun part. We're starting to turn data into information. We're starting to turn our visualizations into something that we can make decisions on and immediately act on and immediately see the benefits of reducing that risk. So once everything is in one database, especially a spatial database, we can ask it a bunch of questions. We could say, is my concrete quality consistent? We can look at depths where we have insufficient overlap continuing on the barrier wall. Can we look at data across multiple projects? This is something that's less common, but getting more so. It's one thing to look at a single project database, but what if I compare the last 10 projects I've done? Can I draw some trends and look at, for example, the effects of rock quality on production rate and have this information affect our mechanics and our engineering design, and literally infinitely more. So there's a number of ways that there are of slicing and dicing data. So here's a geospatial analysis. I love to show this one. This is a slice through the Wolf Creek Dam, Army Corps owned, and the contractor here was Treviecos Solitanche joint venture. This is a cut through a secant pile wall at 180 feet depth. And the simple question we had to answer here through geospatial analysis is the wall wide enough? And the way we've done that is color-coded these calculations of the position of a secant pile at this depth by their overlap. So there's no orange overlaps, which means the overlaps are at least within specification. But then we've also drawn two color-coded polygons in the background. The light green one represents the specified width that the contractor had to build, and the blue one is the calculation at 180 feet of the as-built shape of the wall. So the simple question becomes, do I see blue on either side of green all along the secant pile wall? And if I do, I've boiled a whole bunch of 3D information into a simple answer: yes, the wall is sufficiently wide at this depth. But we still need to print something, and we still need to sign something, and we often still need to archive a PDF. So this is the same kind of thing, but in a one-page printable format, just depth cuts along adjacent panels, and we can throw in this red polygon representing tolerance, which gets greater as we go down. Some annotations represented the overlap. Still a lot of information in a database tried to squeeze into something simple. And for consistency, here's the same thing in profile view, where we've drawn the consistent profile of the panel based on the excavation. And these blue lines are the continuous profiles of the adjacent panels, so you can see the overlap at virtually every depth along. So somewhere between visualization and analysis, we arrive at something that can be printed. Now, the real fun here comes when we put all these software packages together. It's one thing to have a grout monitoring device and a borehole tracking tool, etc., but information management systems are the results of tools all working together. Here's a simple example of an information management system built to service a lot of needs on a small project. This is Malcolm's project, where they've installed diaphragm walls around pier elements. And this is a website that they use in the field, where they can, with their phone or laptop or tablet, enter some basic information on given piles so that the database knows when a panel has been installed. And then they run a coding survey, which is a three-dimensional ultrasonic tool to look at the shape of an excavation. And they can just drag and drop these files into the website, and you'll see in a few seconds they'll disappear because they've been added to this appended folder, which means the database has the data and can quickly create one of these reports showing the profile, the overlap, the as-built information, and whatever else the contractor needs to get this pile approved. So lots of different tools working in tandem to make the information management system, in case we didn't define what one of those was at the beginning. All right. So where else are we now? This is me as a student now, walking around exhibit halls and seeing what people are doing. I'd like to see more of this artificial intelligence to interpret trends in instrumentation and other metrics. And we mentioned this before, the Internet of Things is a little pithy term to describe how any mechanical device on Earth can be Internet enabled and talk to every other device. So the obvious solution in our industry might be intelligent monitoring networks, everything talking to itself beyond the data acquisition system into something more intelligent. So in conclusion, at least my view of the current state of the practice is we're using PIMS tools to collect, to compile, to visualize, to access, and most excitingly, to analyze GeoFoundation's data, often in a geospatial context. And we're turning this data into information to reduce our risk and to keep everybody looking at the same data and happy with the construction. Now I'll turn things back to Massimo with another vision.
I did my check-in, ready to drop in baggages, and boom, blockchain. Come on, really, what's happening in this airport? Well, blockchain. So what is blockchain? I did my homework there. The company they were advertising is called Maersk, is the largest container ship and supply vessel operator worldwide. They manage 150 ports, more than 3 million containers, and the business worth more than $4 trillion. Every single vessel that goes from port A to port B generates kind of 200 interactions and generates 4 inches of documents. I think that you will talk about that, right? So they introduced blockchain and smart contracts, and they increased the number of vessels by 15% and reduced the operational cost by 15%. So blockchain is not a game, eh? Well, probably many of you can associate just the blockchain with Bitcoin. We are not talking about dark web, all the stuff here. So just to clarify that, blockchain is to Bitcoin as internet is to email. So through internet, we can do so many things. One of these is using emails. Same thing with blockchain. One of the things that we can do with blockchain is cryptocurrency, but it's not the only one, actually. It's not probably the most important one, according to our visions. So what is a blockchain? Blockchain is a database. It's a secure, distributed, decentralized, immutable, peer-to-peer based active database. And the keywords are in bold. So what I'm doing now is a kind of magic. I'm trying to explain you guys the blockchain in 1 minute. So imagine that there is Bob. He's going to send a transaction through Alice, that is somewhere else. So he has his own computer. He's running the blockchain software. Submits the transaction. Transaction is analyzed and accepted, and then the transaction is broadcasted in and propagated in a pool of unconfirmed transactions. So all the transactions coming from the people go in this pool, and then we have the miners. Probably you have heard this word, the miners. Who are the miners? Miner is just a software that runs on a very powerful computer that has to execute a very complex algorithm. So what the miners do is pull out the transactions from the pool and run this very complex puzzle to build a block. Just one of those miners will be successful. I mean, the first one that will build the block is the winner. He will be rewarded by that, because of that. And then the block is ready. So what happens next? The block will be propagated to the network, through the network, and will be included in the rest of the blocks. So we have the blockchain. And this is a distributed database because all the machines in the network own a copy of the blockchain. So the blockchain is totally distributed. And then eventually Alice can access the blockchain and retrieve the information or get the confirmation about the transaction. Now, there is something else in some blockchains, because when we think about blockchains, we are not talking about just one object. There are several implementations of the blockchain. In one of those implementations, in the Ethereum implementation, we can also run smart contracts. Smart contracts is an automatic generator of transaction that generates a transaction according to some conditions that can be retrieved from the blockchain. Like if I get $100 in my pocket, let's give $10 to Vanessa. So this is a condition, and the smart contract can automatically generate that. Imagine how can we use this? Life of pressure transducer. Imagine that all the manufacturers agree to utilize the blockchain. So every transducer that is generated will create a transaction in the blockchain, and then we have transactions about the logistic, and then we install the pressure transducer on our rig, and we have data about this transaction and certification. So, and then eventually we can pull out all this information, and the approvers can approve our grouting goal just because the certification are okay. So this can be done pretty easily through implementation of the blockchain. Recap, what is the blockchain? Highly secure and immutable database, decentralized, flexible, scalable. I would like that you guys put a little bit of attention on the bold one, on the bold item. Stores not duplicable digital objects. Right now, if you have, say, music that you downloaded from internet, and then you copy this music and give the music to someone else, you basically have two originals or two copies if you like, but those two items are the same, are identically. Using the blockchain, we can understand which one of those two is the original one. So protection. That's it. Vanessa will tell you the story about what the owners want.
All right, so good news. Rick, we're going to talk about construction. I like talking about construction. I like talking about data. You know, some of the blockchain stuff, when Massimo first started talking about it, I'm like, okay, hang on a minute. We're still trying to get folks to use a database. And so we're going to tell you a little bit of a story. You're going to see a few of the projects that the Corps of Engineers has worked on. We have used these tools and techniques on multiple projects. So there's only going to be a few of them here to kind of cover in this few minutes. So again, kind of talking about this from the owner's perspective, why do we care? I mean, other than it's great to have the newest, greatest buzzword when I'm walking through the airport and show off to my college friends when they're like, I'm working for something in Silicon Valley. I'm like, oh, yeah, no, I got this blockchain thing over here. You know, it's great. You just string it all together. Maybe you don't even know what it means. It sounds great, right? It's exciting. It's on the cutting edge. But we got to use innovation for something. We have a need for it within our industry. And so my biggest question for you is, how does your data flow? And chances are most of you, unless you have been involved in one of these data management type situations, have not actually thought about it. How does it get from the place where it's generated all the way through the process to where your designer actually has contact with the data on what's going on in the middle of construction? The biggest value for us as the Corps of Engineers with dealing with information management of this kind is that it brings our designers all the way back completely into the process. Because even when I'm not standing there getting mud on my boots or grout on my boots, which is making me happy, I'm stuck back in the office, I can log into these systems, I can look at what's going on, I can analyze the data, I can get a call from Dave Paul across the world and say, hey, would you take a look at this one little area over here? Okay, let me download this data. We're going to go here, we're going to put some analyses together. Hugely important. Now, when you first get started on a construction problem, here's the project, here's the problem. It doesn't seem like it's that bad, right? When you get started, you know, we've got a few submittals here and there. We're mobilizing equipment. We've built a work platform. Not a big deal. And, you know, it's kind of quiet. Maybe we've got some new instrumentation we've put in. We're getting ready. And you think, okay, fine, my system is ready to handle this. Well, here's the problem. Most times, it's not. And you find out right here. Yeah, this is not a doctored photo. This is Wolf Creek Dam. This is, you know, it's been a little while since we did this project, but that's a lot of equipment. Every piece of that equipment is generating data. A lot of that data I had to look at. My team had to look at. The folks that I worked with had to look at. We were looking at it out in construction. We were looking at it back in the office. And then when we got done with the whole project, we had to prove that what we did actually worked. So you got to be able to figure this out. We've got to compile this stuff. We've got to analyze it. We've got to compare it. This is 980,000 square feet of a barrier wall. 980,000 square feet, okay? 270 feet into the karst foundation. There's a couple numbers you need to be paying attention to because you cannot handle this stuff with our old systems. This is just the instrumentation at Wolf Creek Dam. We had more than 3.2 million readings. 3.2 million. One or two, okay? How fast can you type that in? Yeah, exactly. So the construction data that we generated on Wolf Creek, and this was one of the projects that really told us that we had to modernize our systems with dealing with this stuff. There were 71 million records generated on that project. We had over 25,000 plus files. We had 36 gig on one drive. We had 200 gig on another drive. And if you printed out every single barrier wall element report, like actually take the PDF, print it out, and stack it in a pile, it's 144 feet high. Now, do you really want to use file boxes? Right? Don't you want to use a computer at this point? Because that's a lot. All right. Center Hill Dam, it was the same thing. This is something that came in. This is a barrier wall project that we did after Wolf Creek Dam. 330 feet in depth through the dam into the underlying rock. We had a double-line grout curtain. We had a lot of work that had been done on the project before the barrier wall project was being constructed. So you've got all of the new equipment. You've got everything that happened on the grouting that was done fairly recently, a few years before the barrier wall was put in, and you have everything that was done in construction when they put this project together. And, oh, by the way, there was a 1980s grouting program. So do you think that all of those things might have had an influence on what's going on in the subsurface? So if you're going to understand what you're doing with an invasive procedure, like I'm going to drill a hole through my dam and I'm going to put concrete in it to build a barrier wall, this is very invasive. You've got to understand the context. If you don't understand the context, you're not going to be able to explain why some things happen on your projects. We had more than 7 million readings for our instrumentation for Center Hill Dam. Again, I don't know about y'all, but it would take me a little bit to type that in. But once you've got it, it's not just typing it in, right? It's analyzing it. What good is a database you don't look at? How good is your data? What good is it doing you, this immense resource, all these numbers, if you can't actually analyze it, if you don't spend the time to say, okay, what is this instrument right here doing, and what is it telling me about what we're doing in the foundation right now, and what does it tell me about my long-term risks and monitoring of my project? So again, so as Massimo actually mentioned earlier, if you've got 10,360 unique stages of grouting, and 1,368 grout holes, and you've got a big old pressure spike in one particular instrument, which one did it? Trust me, you do not even want to try to do that by paper. Not fun. That's way too many things. What happens is the information gets buried in the data. So if you don't have a system that can cope with it, you're going to lose track of things that you need to know. So now we're going to talk a little bit about Mosul Dam in Iraq. It's a project I know a number of you in this room have heard of. And again, the problem was lots and lots and lots of data. We had drilling. We had QA monitoring, QC monitoring. You've got people on site. You've got measurement while drilling. You've got grouting. You've got grout pressures. You've got all of these other things going on all simultaneously. And trust me, there wasn't just one rig running at once. All right, now, lots of data sources coming here, there, and yon. So what's going on and how do you put it together, right? There's 4,800 grout holes, 526,000 meters of drilling and grouting. If you line them all up, that's more than the distance between D.C. to New York. 41,000 cubic meters of grout and a lot of instruments, old instruments, new instruments, some that were working really well, some that were not. And so when you have something going on and you're doing this drilling, you've got to be able to say, this instrument reacted to this activity. Here's how far they are, and here's what it means. And if you've got all of your information buried in 15 places, you're never going to know that. So the thing is that it doesn't even matter if it's big data. It sure as heck big enough. You have got data sources coming in from everywhere that are going to try to drown you a little bit. Oh, sorry, cut off the sound. There we go. It's coming in at you quite quickly, and you've got to be able to react to it. You've got to be able to figure out how to capture this data, how to deal with it, or it's going to be out of control. Up in your face. There you go. He's got his data management system ready now. He did it. Okay, that was fun. So we had all this, yeah, you know, come on, man. There's nothing that's not fun about a video like that. It's almost as good as blowing up rock. All right. So we had a lot of data coming from all kinds of places, drilling and grouting, water pressure tests, artesian pressures, QA observations, historical documents, which we were getting as the project went along. We didn't even have all of them as we got started. So you've got a grouting database that's actually being run by the contractor. You've got a QA database that's capturing QA observations, and everybody's got to get all these pieces and parts and into one system and be able to share that data back out with everybody else. And until we can do that, we're not actually effectively managing the data. And that's what we were doing. And we developed some tools and we put it all into a database. We had a lot of conversations. It was not perfect. There were certainly times when, you know, you're sitting there and you feel like you got the wrong plug. You ever done that? Like you pick up your hard drive and you realize you got your USB connector to your phone packed in your bag, and you got a hard drive and you got a USB connector to your phone, but I can't plug my hard drive in. These things happen. And so figuring out that data flow is really, really important. And we used a geodatabase, did a lot of this spatially, it's the same kind of things that we're talking about. Used a GIS platform because it was a tool we had that we understood, it was easy to work with, and delivered this stuff back over the web. And then also we used them internally with our GIS software to do data analysis. And we did a lot of data analysis on this project. The web software was really handy because we had so many different things going on, and you could click on a grouting stage. You could see actually what the geology was in the background. You could actually get the time history plot. You could get some of the other data associated with that hole, and it was all kind of at your fingertips. Instead of, I have to go to a file folder and search on names that don't make sense, and thousands upon thousands of files. And that's what happens if you don't put this stuff together. Because when you're generating this volume of data, you're simply going to lose it in the vast amount of what is coming at you. So the question is, how good is your database? How many people in here, and you don't have to raise your hand, I'm not going to shame anybody, but how many people in here really think Excel is your database? Okay, yeah, there's a lot of you, I know. Yeah. There's a lot of you. And we've done it too. Actually, the background right there is J. Percy Priest Dam. That was the instrumentation database that was implemented at J. Percy Priest Dam in 2013. Well, we also had WinIDP, but this is what they were keeping at the job site. This is how they figured out what was going on within the instrumentation. Yeah, so that's great when you have a couple of instruments and not much data. When you have something like this, totally does not work. Can you get your data to everybody that needs it? Right? Are you delivering it fast? Or are you Mr. Snail over here going, well, I'm the pokey little puppy, I'll get there eventually, you know? And how do you keep it from people that shouldn't be looking at it? Right? There are times when you're going to be generating stuff that not everybody needs to see. So you got to be able to get it to all the people who need it, keep it away from those that don't, and deliver it at the speed of relevance. Because if you deliver it too slow, sometimes you might as well not have delivered it. All right, so telemetry. Can you get your instrumentation data from your dam back to your district office? That's a big deal for us. We're using SneakerNet, right? I mean, when my workflow is Scott Massa, go drive 2.5 hours, go download the data off my automated monitoring system, drive back to the office and give it to me. Okay, that may be too long. For some times, that may actually be okay. But a lot of times, that is simply not going to be enough. So imagine getting data from all of these kinds of different instruments, stuff in the gallery, and this is even before some of the things were even installed. Grouting data, INSAR data, field observations, all of this stuff going on this project, and try to get it across 11 hours of time zone. Okay, you can't do that in a box. You're not going to do that with paper. Ever tried to mail something from, northern Iraq? Takes a hot minute to get from one place to another. You've got to be able to do all this and get it to all of the people that actually needed to be working on the project and involved in the analysis. Now, the other thing is that speed of information, and I got air quotes here, information, can be a real problem. This is actually back at Wolf Creek. I got a call one day that said, oh, we got a problem. The work platform at Wolf Creek Dam is moving. We just did a survey. It's moved 1.5 inches toward the lake. We might need to shut down the job. Okay, that's going to get everyone's attention. Do you know what that costs? You suddenly tell your contractor, stop working for a minute while we figure this out. And it was true. That's what the results showed, that the work platform was moving. Unfortunately, it showed that the work platform was moving. Let's see, I don't know if I can point this with this thing. Over here, and right here, and in the curve, and over here, and oh, by the way, the concrete dam. And they all moved at the exact same angle and the exact same rate. What does that tell you? Oh, yeah, okay, it tells you you had a bust in your survey. It happens, not a big deal. Except that it's amazing when no matter how many bottlenecks are in your system, if it's bad news, somebody hears it really fast. So while you're sitting there trying to figure out what's going on with your survey data, your lieutenant colonel is knocking on your door. What's going on at Wolf Creek? Sir, hang on. So you've got to be able to get the right data at the right place at the right time, because erroneous data, rumors, all that other stuff, travels way faster than you think. Actually, I think it breaks the laws of physics, but I'm not sure how that works. All right, so just that was a lot of the near field, kind of what we're working on right now. And there's still plenty of room here, by the way, for anybody that's doing research or work out in this area. But just a couple slides on vision for the future. We spent a lot of time and effort putting together 3D models of our projects. Okay, I don't know why that's happened out there. Sorry, guys. But if you could see it, I've got a really nice 3D model of J. Percy Priest Dam with a little drill rig sitting on top. It's very cute. But here's the deal. What's important about that model is not some flashy little thing within a presentation. What's important about it is what it tells me about the risks that are presented by that dam. That's what's important. And so we've got to be able to take those out of that 2D space and really try to get it into 3D space. We've spent a considerable effort generating all of this data, putting all of these things together, these grout lines, all of these things, and we've organized it, we've visualized it, we've analyzed it. You know, I've got a really great 3D drawing. Oh, you can even see it. This is awesome. All right, it came back of some grout around some pipes, and then another one of actually Center Hill and some geophysical results. But we got to get it off the 2D screen because your eyeball doesn't see 3D very well when it doesn't move. Put it into 3D space and trust me, things pop out at you that you don't realize you're missing. Again, it's that kind of that jump into taking that data and really turning it into usable information. And with that, my friend Massimo is going to wrap us up.
No? Yeah, okay. So, well, eventually we have all those data, information, blah, blah, blah. We have to look at this information and use those information. 2D, as Vanessa said, and as Gianfranco said initially, is not enough anymore. We need to be more involved, more immersed in the data and the information. So, and this is where the virtual reality kicks in. When we think about virtual reality, we think about different technologies. In reality, we have three virtual realities. We have the virtual reality itself, that is, the user is totally immersed in a fully artificial digital environment. There is no interaction with the surrounding environment. And examples are Facebook, Oculus, and HTC Vive. And then we have the augmented reality. Probably your next car will have something like that. Virtual objects overlay the real-world environment. So while you are driving, you can get information about speed or signals, whatever. And examples are the Dakri Smart Helmet and Google Glasses. And then we have the mixed reality, and this is what we want to focus on. In Rome last year, we had a hands-on presentation using HoloLens and a model of the East Branch Dam. So with mixed reality, virtual objects, mostly in 3D, holographic objects, overlay the real world and are anchored to it. What does it mean? And the tool that can do this is the Microsoft HoloLens. What does it mean? It means that you can walk through your job site and you can just look around, and while you turn your hand left, right, you see the features, you see whatever has been built underground, and you can just click on that holographic images and you can retrieve everything, all the information that you need. Microsoft is announcing the HoloLens 2 that will be totally a game changer, because that tool will be, by the way, I'm not associated with Microsoft, but that tool is really more powerful, can work outside. So it's definitely something that will change the way we use information, we look at information, the way we will immerse in the data world. HoloLens 2 versus Mr. Spark, Avengers. I don't think that we are really far from this. Sci-fi and reality. Looks to me pretty the same. Thanks, Guy. Ride wave of innovation. I hope that you enjoyed the PIMS presentation. Thanks for having us.
Well, you can understand why I want to be with these guys, right? They are incredible. They have so many ideas, and still I don't understand all this, what they explain it, but that's okay. But we understand one thing, that really we need to change. We need to understand that data are more important than anything. And yes, now the government, the big clients are asking for this, but soon everybody, every project, every place, even the remodeling of the house will require this type of data that have to be given to whoever work on control, on give you the permit to build the house. So I want to ask you a question. Do you know what is this? A telex. How many people use that? Okay, there are a few people. I did it. I did it in Iraq in 1980, and that was my system, the first system that I really used to transfer information, of course typing, to Milan, to Italy, during the war between Iraq and Iran. I was never dreaming about what's going on now. The cell phone, the computer system that we have now, the possibility to use a HoloLens, etc. I cry when I use a HoloLens the first time. But I don't know what will be the future. It's incredible. I cannot dream what will be the future. And we have to be on the edge as a DFI to be part of the future and to introduce all these things in our technology, in our work, as owners, contractors, engineers, consultants, academia, all together. Thank you very much. And if you have any questions, please.